Okay. Optimal policy. And optimal value function. First of all, the solving RL. What solves in the RL? Finding a policy, achieving a lot of reward. Over long run. For example, if we have the pi, and so we need to continue the pi prime, right? The next policy. If pi value or state value function is smaller than pi hat value, okay? And so, what's the optimal policy? Optimal policy is that pi prime, if and only if v pi s is greater than v pi s, okay? Which means that if you have the policy in terms of what is the related value function is given in here, and so if one of them is greater than this one, and so we need to choose the bigger one in here. This directly relates to the what? To the value function. And so, what's the optimal policy in here? Optimal policy, pi star. Just remember this one. And so, for optimal state value function, v star, which is given by v star s, is equal to what? Maximum pi under the pi policy. And so, in English, or in meaningful form, if we have the policy to maximize the R value function, v pi, and so we can call it to the v star. This is the best state value function. Okay? And so, what is the optimal action value function? Optimal action value function denoted by q star, and we can define it as the what? Q star as a, which is equal to the max pi q pi s a for all what? S elements of S, A elements of big A, or the cluster of A. Okay, these are the definition. And so how can we collaborate these two equations into the one? So collaboration is that if we have the q star as a value, which is equals to the what? This is equals to the E R T plus 1 gamma pi star S T plus 1 for a given ST S A T A. Okay? Because if this is the case, just see that max pi v pi, which is equal to the v star, right? And so the v star is the what? The applied pi values of the state in here. And so the q value is the what? Is the r nomination of these terms. Okay? And so the next position, next best position is discounted, and plus the current reward is added, gives us the what? The action value function. See, q is rewritten in terms of the what? In terms of the v, or the v is, or can be written as in terms of what? The q function in here. Okay? So, just see that we need to write some expressions in here. The Bellman optimality. Equation expresses to what? The fact that the value of state under an optimal policy must equal to expected return for the best action from the state. This is our rule. This is our link with the future. Based on the what? Based on the action. Okay? How can we formalize it? In this case, we star S, which is equals to the what? The maximum values of the S cluster. Okay? In this cluster, so we can choose A with maximize to the what? To the Q pi star values. Okay? So, these are the equation. If we choose the maximum values or the giving to maximize the Q function, and so we get the V. Okay, and after that we can expand to these terms in terms of the what the E pi from the definition of these terms. This is the GT, ST, and which is S, and AT, which is A, and so we can continue with what the E pi star in here. If we expand to this term also in here, plus GT times discounted values, ST is equals to the S, AT is equals to the A, okay? And also the max A value, expected value. Just see that this pi star is going to what? Inside, okay? And so RT plus 1 gamma V star right now ST plus 1, and for given STS ATA, and after that the maximum or maximize A values S prime R thanks to Furkan, and S A times R plus gamma times V star S prime can be rewritten in here. Okay, we're just using the what, putting the equation for into the what, into the this one. Okay, what does it tell us? Just see that we can convert the Q action value into the what, into the state value. And also just look at this formula. This formula returns to the what? V star RT plus 1 plus gamma times V star S T plus 1. The next state value, current state value, and reward is a constant in here. But in what condition? If we choose the maximum Q or the maximum A values in here, the best action, and so we can use this formulation. This is the Bellman definition. Okay? And so, for just now, maximum values, Bellman optimality, equation is this one. This is Q star SA, which is equals to what? The expected values are T plus 1 gamma maximum A prime. Right now, Q star S T plus 1 A prime S T S A T which can be given in here. Okay? Okay. So, in this case, we need to continue with the dynamic programming. It's important to know what is the past in here. Otherwise, we cannot learn how the RL algorithm improves the R methodology, right? Or methods. What's the advantage of the RL? Okay. So, the DP. It's the algorithms that can be used to what? To compute optimal policies given a perfect model environment as a MDP. What's your name? Emir. Just come here. We will continue with you for this case because you know the agents and the LLMs. Okay? I like you. So, in this case, what is the perfect model? Perfect model means x dot equals to what? Ax plus b. We know the a, we know the b, we have the perfect model. Okay? Just that's it. For the formulation of DP, we need to use the finite MDP. Emir, what's the MDP? Huh? What is MDP? It's too important. This is a transition dynamic for a given position and the next position, okay?
Also decision process.
Yes. Yes, yeah, what's it?
I don't know.
Okay, just continue.
Okay.
Yes, yeah. So, the problem formulation is that we have state, current position, and action, and related to what the result of this SNA report, okay? So, these are finite, but in this process, we can choose the continuous or the discrete action. In the computer science or in your life, you choose always a what? A discrete process. You can decide in the discrete form, but you can feel in continuous form. Okay? The emotions are continuous, but your decisions are discrete in your real life. This is the analogy. And so, what it discretize the continuous and apply dp. Okay, what's the meaning of this? In the discrete form, we have just right now a transition probability, okay, for dynamic, because we don't know what is the next move. We just guessed, just like the agent image, right? 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 Bunda ne zaman söylesem o gif geliyor aklıma. Kimdi o aslında? Keira Knightley miydi o kadın? Natalie Portman mıydı? Neyse. Key idea of DP. What is the key idea, Emir? Using value function, Emir, this is important right now to organize and structure for good policy. So, we have the what, the states, and the actions, okay? And so we can calculate to the what, the next state, next state, next state with a perfect model. And so we can generate to 0 to 10 times discrete space within a matrix. And so we need to find out what is the best action in here. But we need to know how we can choose the best action. This is called policy, right? So, Bellman equality gives us to what? Just remember the previous lesson. Bellman optimality equations gives us to what? V star S, which is equals to what? The maximum, or the A selected to be maximized in this case, and E are T plus 1 plus gamma V star S T plus 1 for a given what? ST, S, A, T, A. Okay? These are the Bellman case. We linked the current value with the next one, right? And so we need to find out what is the best action in the local form, right? So, in this form, the transition probability of this one, this is the collection of the what? S prime and R, transition, RSA, and current R times V star S prime. Okay? This is our case. If we waited to the whole the rewards and the next case, and if we collect based on what the possible next states with a reward, and so we can choose the best state value function based on the selection of the age. Okay, that's it. So, Emir, what is it right now? Just remind me. T plus 1 gamma times maximum values of the A prime, the next best action, Q star as T plus 1 A prime in here for a given STS ATA. Okay, and so it is seen in the probabilistic domain just like this one, not a maximum value right now, just S and R, P, S prime, RSA, A, and R times gamma maximum A prime, Q star, S prime, and A prime. Okay? This baby looks like a complex, but it's not. Emir. Just simple. We have...
Veriyor benziyor sanki.
Huh?
Temperature veriyor el elemdeki.
It's just like this one, but it's not. If we weight these values with some forms, if we add the softmax layer in here with a coefficient, this is called the temperature layer. Okay? So, that's good analogy. I like it. In this case, we need to write the two forms. We need to evaluate and improve our algorithms. Just like the agents, right? Firstly, we need to evaluate all the conditions, and after that, we need to create a plan to do so. And so, after that, we need to improve our code or task based on this one. What is the basis of these terms? What's it? Where is it coming from? This is called policy evaluation. If you give any agent to do your code or paper or your homework or some task, we need to evaluate it to find out the state value function. Where is it? So, what is the reward of this case in the agents? Just think about it. If you give some prompts, you define the reward value, right? Right? Huh? Oldu mu? Do you understand? And so this prompt is a reward, defines the reward function. And after that, we need to evaluate it based on the what? Based on the truths or the facts. And so how can we evaluate this case. The problem is how to compute state value function v pi for arbitrary pi policy. This is called policy evaluation or prediction, right? So, what's the definition? V pi s, which is equals to what? The weighted factor of the a pi a s times s prime r p s r s a times reward gamma times v pi and s prime. Okay, that's it. This is our case. So, in math, what is the meaning of the gamma values? The gamma contains or the proves existence, uniqueness of v pi guaranteed by gamma 1. This is the mathematical condition to what? To solution is exist in here and it's unique. In your prompts, in the LLMs, it's not a unique. And so the codex or cloud can complete this text based on this. Okay? And so if you give the some prompts in your agents to the LLMs, and so you automatically define your rewards in here. And so this reward is defined, and so your agent calculates firstly the state value function. And after that, it converts with the maximum values of the what reward in here and defines the action values. And after that, generates to the what? It generates your results based on your reports. Okay? So, yeah.
Hocam mesela şimdi ya tamam birinci herkes bunu yapmış. GPT'ye bir soru atıyorum.
Hı.
Diyor ki bunu çöz ya da öğretmen gibi açık veren çöz.
Yeah.
O öğretmen gibi dediğimiz kısım polisiye mi giriyor?
No. It's a reward. The whole inputs are the reward. Okay? They have policy, but you restrict it based on your conditions. Okay? Just see it in that way. And so the environment dynamic is known in the system of S converted into the what? This is the whole elements number, the number of the elements contained in the S value. If we have the S1 to 5, and so this returns to the what? 5 values. This is the technical term, okay? Into linear equation, okay? This is called a matrix, right? In S unknowns for V pi S. S, okay? That's it. So, using the Bellman operator right now. Emir, what is the Bellman operator? Or equation? Just remind me. Just tell me. Why do we need to use the Bellman operator? This is the core of the everything. V pi. The update rule is just tell me, Emir, say something. Huh? Okay. You don't know these terms, and so the Vk plus S should be written in here in the probabilistic rate of these terms also. and S prime R. I will explain in here, but I just write it firstly. R gamma VK S prime. Okay. These are the two rules. To what? To update rules. If we know the dispositions in here for a distinct terms, and so we can calculate what the next policy or the next conditions in here, because the k plus 1 and k plus 1 or k, which is given in here, because just see that in this case S prime is given to the what? To this one. This is the next state. But this is the current state. But the next state is given here. It's a recursive, right? Can imitate this results of these terms. Okay? This generates to the what? The iterative policy evaluation. Iterative policy evaluation. Okay? And so, how we can write the conditions of these terms? This is called iterative policy evaluation. Okay? So, how can we write the pseudo code in here? Iterative policy evaluation. So, first of all, we should write or create the loop, and we should define the delta, which is equals to the 0. And after that, we should create another loop in here for each of the what? Each of S, elements of S. We search the whole S. For example, we have the 5S, and so we create the loops. Let's try to what? Find out what's the best, okay? And so the V is assigned to the Vs. And after that, the Vs is set the new or the next values of these terms. The weighted factor of the pi s, the policy weighting, and S prime and R should be given in here as RSA and times R and gamma times Vs prime. Okay? And after that, we need to calculate the what? The maximum values of the delta and V minus Vs in here. Because this is the what? This is the previous value. This is the current value, right? We want to clear to the what? To the difference values between the k plus 1 and k. Which means that we can control these terms, or we can use these terms in order to what this system is going to what steady state. There's nothing changed in here, for example. So until to what? Delta smaller than theta. This is our threshold. This is called the iterative policy evaluation, guys. Okay? What does it mean? 4.2. Policy improvement. What's the purpose of these things? Finding better policy. Suppose that we have determined pi or v pi in this case for an arbitrary. What's the meaning of the arbitrary, Emir? Furkan?
Geçici.
It's not a geçici. Herhangi. Anladınız mı? Rastgele değil ama herhangi. Deterministically an action claiming A not equals to the pi s. And so we need to consider that. Is this good or not? In order to improve anything in here, and so we need to check it. Is this good or not? Okay? We need to measure it. So this is our purpose. The value of this way behaving is like this one. Q pi for a given SNA, which is equals to what? The E are t plus 1 plus gamma v pi s t plus 1 for a given st s a t a. Okay? And so the collective term of these terms is the transition probability of the what of this one. R plus gamma v pi s prime values. Okay? This is our conditions. But in order to evaluate the whole the conditions, v k plus 1 and v k must be compared. But in order to improve your action, we need to compare to the what? The general condition. Ulan niye gülüyorsun? çok mutlusun. You're so happy. Okay. General condition of improvement is to what? Q pi s pi prime bigger than v pi s. Right now, this is the general definition of the improvement. Okay. So if this is true, and so we can say that v pi prime s bigger than v pi s. This is the other conditions. Okay. And so these two combination gives us to what? Pi and pi is deterministic policy, not the probabilistic one. Okay, just remember that. And this two also gives us to what? The policy improvement theorem. Okay. One of them is the action based, but the next policy is increased to the what? To the effective of these terms, and so we need to compare to v pi because the second condition guarantees that. Okay.